things first, if you hear any piano in the background, I apologize. That's my son practicing. Never mind, that's my wife, according to my son. But anyway, I want to review this real quick for the test. This is an exact section off the test. I've changed these numbers though, and the elements, so it's everything's different. One of them's the same, but whatever. Everything's pretty much different, but the process is exactly the same. So what I want you to do, so it's giving you this element and asking for the numbers of protons and neutrons. And for a handful of you, this will be easy. You'll be done in 10 seconds already, but I want to make sure you understand, and we review this part since I was gone this day. If you have magnesium and 24 and 12, now it doesn't matter. It might be Mg 12 and 24. Either way, these are the same things. You always need to remember that the smaller of the two numbers, it doesn't matter where they are, but the smaller one will be equal to the atomic number and the number of protons. I'm out of room, but whatever. That's what the smaller number is. All right. It also corresponds to the number of electrons. Sorry to pause that and yell at my kids for a second. It was a nice yell though, so don't worry. All right, then the larger of the two values, and remember, it doesn't matter what way this is written, big on top, little on top, it doesn't matter, but the larger of the two numbers, that will be your atomic mass. This is ugly because I'm writing with my finger on my laptop. That's your atomic mass. And your atomic mass is equal to, I'll type this, your protons plus your neutrons. All right. So you have to be a little bit smart here to figure out over here as it's asking. You have to be smart to be able to figure out the number of neutrons. The neutrons will be equal to the difference between these two numbers. So you just subtract the little from the big. All right. And that isn't rocket science or anything. That's just coming from the idea, once again, that our protons and neutrons will equal the big number. So here we go. First off, number of protons for magnesium, that's just equal to the smaller number. That's a 12. All right. And then the number of neutrons, you would just take the big number, which is 24, subtract 12 from it, and that will also be 12. Now, oftentimes they'll be the same number, but sometimes they're not. All right, so nitrogen here, I'm going to clear out a lot of this stuff, all of it pretty much. So nitrogen, we have N, 7, and 15. Protons, remember, comes from the small number, so that's a 7. All right, then the neutrons come from the difference between the two values. So you take 15 and subtract 7, and that will give you 8. Now notice, this is not how it's listed on the periodic table. On the periodic table, nitrogen is 7 and 14. That indicates that nitrogen with a mass of 15 must be an isotope, as it was written there. All right, let's clear this out. So the next one we have is argon, and now we have to be a little bit smarter. When I changed this, I didn't change that number. So ignore that for a minute. We'll just put a 20 right there. All right, so argon now, we have to figure out this top number, which is the smaller of the two numbers. Now you can do that pretty easy from the periodic table. If you look at argon, it's Ar and 40 and 20. All right, so the number of protons will be equal to the smaller of these two values from the periodic table. Then that is actually also equal to the atomic number, because these will always match, because that's where that number comes from. So for argon, it's 20, 20. So its atomic number is 20. The number of protons is 20, and the number of neutrons is 20. And that was just 40 minus 20 is 20. All right, pause it for a second and see if you can do uranium. All right, uranium's a little bit harder. This says it's an isotope, so it's not the one listed on the periodic table, but we know it's element number 92, and then we know it has 142 neutrons. All right, that doesn't tell us the total mass. The total mass will be the 92 plus 142. All right, the two numbers. So this number should be the same, 92. And then so 234 maybe. If I did that wrong, it's hard to do math under pressure. Anyway, that is how you would do that. So one more just quick review here. These two numbers will always be the same. And then the neutrons will either be equal to the atomic mass minus the protons for those. All right, or down here, it will be these two numbers added together. Hopefully that will help you be successful on this part of the test.